Histograms are similar to bar charts, but the bars do not need to be the same width, and there are no gaps between the bars because a histogram demonstrates continuous data. Here's a question involving a histogram. The time t taken by staff at a supermarket to scan 5 items at their till is shown in the table. We need to draw a histogram of this data. And to do that, we're going to use the formula frequency density is frequency divided by class width. Frequency density always goes on the y-axis of a histogram, and the time or the variable goes on the x-axis. To draw my histogram, I'm firstly going to fill in my frequency density table. So between 0 and 4 seconds, the class width is 4 take away 0, which is 4, and the number of staff, which is frequency, is 0. So to work out the frequency density, I just do 0 divided by 4, which is 0. Between 4 and 8 seconds, the class width is 8 take away 4, which is 4. The frequency is 2, so I need to do 2 divided by 4, which is just 0.5. And I carry on like this to complete my frequency densities. And I'm now ready to plot my histogram. So between 0 and 4 seconds, that means there's going to be a bar between 0 and 4. But firstly, let's do the scale on the y-axis. The highest frequency density value is 6, so a sensible scale is 10 small squares to make 1. Then I've used most of the space available. I'm now going to draw the histogram. So between 0 and 4 seconds, I need a bar, well, I don't need a bar actually, I don't need anything between 0 and 4 seconds. But certainly between 4 and 8 seconds, I need a bar which is 0.5 units high. And I carry on like this. So between 8 and 12 seconds, I want a bar which is 6 units high, and so on. And there is my completed histogram. One thing to note is that the frequency, the total frequency, is essentially the area under the histogram. The total area under the histogram will give you the total frequency. Here's a question for you to try. So get some graph paper, and I'd like you to plot the histogram for the information on the length of worms given here. When you're ready for the answer, press play. Here is the answer. So you should have these values for frequency density. And then when you plot your histogram, it should look just like this. Very often we need to interpret histograms, which means that we'll need to rearrange the formula frequency density equals frequency over class width to get frequency. So to get frequency on its own, you would multiply both sides by class width. So frequency is frequency density times class width. This lets you work out how much each of the bars is worth and how many people or things are represented by the histogram. In question A, we want to work out how many people were served at the pay desk. To do this, I need to work out the total frequency of the histogram. So I'm going to work out how many people are represented by each bar. If I look at the first bar, between 0 and 10 seconds, that's a class width of 10 take away 0, which is 10. Frequency is frequency density times class width. Looking at the height of the bar gives us a frequency density of 0.5, and if we do class width times frequency density, 10 times 0.5, we get 5. And we can carry on this way to work out the frequencies of all the bars. So we can see that we have 5, 20, 40, 30, and then 20. So the total people that were served at the pay desk, to work that out, I just add all of these values up, which will give you 115. For B, to calculate an estimate for the number of people who were served in less than 12.5 seconds, I need to work out the area under my histogram less than 12.5 seconds. So essentially, we need the area under the histogram all the way up from 0 to 12.5 seconds. To work this out, well, I know there were 5 people represented in the first bar. And I can work out how many people are in the 10 to 12.5 section of the second bar by doing class width, well, 10 to 12.5, that's a width of 2.5, times frequency density in the second bar of 2. So I would just need to do 5 plus 2.5 times 2, which will give you 5 plus 5, which is 10 people. For C, the cinema target is to serve 80% of people in less than 40 seconds per person. How many more people in the target were served in less than 40 seconds? Firstly, I'm going to work out 80% of 115, which is 92, just by doing 0.8 times 115. And then I'm going to work out how many people were actually served in less than 40 seconds, which is the area under the histogram from 0 all the way up to 40 seconds, which is going to be 5 plus 20 plus 40 plus 30, which is 95. So, working out the difference between these two values gives me 3 extra people above the target. Here's a question for you to try. Please pause the video now and have a go, and when you're ready for the answer, press play. Here is the answer. We should end up with 12% of phone calls lasting more than 3/4 of an hour. Remember, 3/4 of an hour is 45 minutes, so I've worked out the area under my histogram in this region here, and this is going to be, well, here we can see a class width of 5, frequency density of 2, 5 times 2 is 10, and you can just see it's half of that bar, so it's obviously 10. And then there's 20 people between 50 and 70 minutes. We add them up to get 30, and 30 out of 250 is 12%. The most difficult kind of histogram question is usually when they ask how to work the median out, or that they want one of the quartiles or the interquartile range. Because remember, this is continuous data, similar to cumulative frequency graphs where we worked out the interquartile range. In this question, we want to work out the median length of a telephone call made to the computer helpline and give our answer to 1 decimal place. There are a number of steps to this. The first step is to work out the total frequency given in the distribution. So we need to use frequency is frequency density times class width, and to work out the individual frequencies. For example, between 20 and 30 we have a class width of 30 take away 20, which is 10, and reading the bar chart, not the bar chart, the histogram, reading up the bar we have a frequency density of 10. 10 times 10 is 100, so our frequency is 100 in that bar. And we work similarly for all of the other bars. What we need to do now is work out, now that we've worked out the total frequency, if we want the median, we need to halve this, which will give us the position of the median. We can see the median is the 125th call. What we need to do now is work out which bar this belongs in. Well, we know the first 10 people, the first 10 calls are between 0 and 10 minutes, then the first 70 are between 0 and 20, and then the first 170 are between 0 and 30. But because the first 70 were only between 0 and 20, we can see that the 125th call needs to be in the bar 20 to 30. You basically keep adding cumulative frequency until we are greater than the position of the median. So the 125th call is somewhere in the 20 to 30 minutes class. And to work out what value this is, we need to work out how far into the class we need to go. Well, there are 70 values before we get to this bar. So we need to go in by 125 take away 70, which is 55. So we need to go 55 calls into the class. That doesn't mean that we just go across 55 and 20, because then you'd be outside of the bar. No, what we need to do is work out the class width. Class width is given by frequency over frequency density. And we just need to substitute in 55 for the frequency, and for the frequency density, just the frequency density of the bar, which is 10. So we end up with a class width of 55 divided by 10, which is 5.5. So this estimate that I've drawn here, this is actually 5.5. So To work out what the median is, we need to go 5.5 to the right of 20, which gives us a median of 25.5 minutes. You might also be asked to work out the quartiles, and it's very similar. So we now want to work out an estimate for the interquartile range of the lengths of the worms from the previous question. So to do this, I'm first of all going to find the position of the lower quartile. We know that there are 86 values, that's just from adding up the frequencies, 4 plus 2 plus 10 and so on. 86 divided by 4 is 21.5. So we need the 21.5 or the 21.5th value. And I can see that this is going to be in the 30 to 40 class because we have 6 values between 0 and 20, then we have 16 between 0 and 30, and then we have 36 between 0 and 40. So we can see the 21.5 value is going to be in the 30 to 40 class. 21.5 take away 16 because up to the 30 class there are 16 values is 5.5. So we need to go 5.5 into the bar. We can then work out the class width just as we did for the median before, which is going to be 5.5 divided by 2, frequency divided by frequency density, which gives us 2.75. So we need to go 2.75 into the 30 to 40 class. So the lower quartile is 32.75 millimeters. We're now going to work out the upper quartile in order to work out the interquartile range. The lower quartile was 32.75 millimeters. To find the upper quartile, we need to go 3/4 into the distribution. 3/4 of 86 is 64.5. So that means that we want to find the 64.5th value, or the 64.5th length. And we can work out using cumulative frequency, this is between 50 and this is in the 50 to 60 millimeter class. And we need to go 4.5. The lower quartile is 32.75 millimeters. To get the upper quartile, or the position of the upper quartile, we need to go 3/4 into the distribution. So I work out 3/4 of the total frequency, which is 64.5. So the 64.5th value is going to be the upper quartile. This is in the 50 to 60 class, and you can see that by working out cumulative frequency. And we can work out that this is 4.5 into the class, because up to 50 there are 4 plus 2 plus 10 plus 20 plus 24, which is 60 values. So we need to go 4.5 values into the class. To work out the class width, we need to do frequency divided by frequency density. So we can see that the frequency density here is 2.4. So we need to do 4.5 divided by 2.4, which is 1.875. So to work out the upper quartile, we need to do 50 plus 1.875, which is 50.875. The interquartile range is then the difference between the upper quartile and lower quartile, which is 18.125 millimeters. Here is a question for you to try. Please pause the video now and have a go, and when you're ready to go to the answer, press play. Here's the answer. So firstly, I need to complete the histogram. So to work out the frequency density, we need to do frequency divided by class width. And we have 24 girls between 155 and 160. So we do we do frequency density of, well, to work out the frequency density, we do 24 divided by 5, which is 4.8, and then we draw the bar. These are the frequencies that we should get. And to work out the interquartile range, firstly, we will work out the lower quartile. So the total frequency is 140. Position of the lower quartile is 35. The 35th height occurs in the 145 to 150 class. This is 9 heights into the class. We work out the class width, which is 9 over 6, which is 1.5. So we find out that the lower quartile is 146.5 centimetres. To work out the upper quartile, we need to go 3/4 of the way into the distribution. 3/4 of 140 is 105. This occurs in the 155 to 160 class. We need to go again 9 units into the class, but this time we do 9 divided by 4.8 because the frequency density of the class is 4.8. This gives me an upper quartile of 156.875, and hence the interquartile range is 10.375 for the difference.